AI is now designing space missions. Better than humans? Right now, sending one Starship to Mars feels like running a marathon with a calculator. Teams spend weeks balancing fuel, timing, heat, and orbit math, praying nothing slips through the cracks. That's the world we expect – slow, careful, and human. But something is changing behind the scenes. A new planner is stepping in, and it's already exposing mistakes engineers didn't even know they were making. The wild part? This shift doesn't start on Mars. It starts in the moment the rocket leaves the pad, and what happens next is the part nobody's ready for. The real question is, how far can it go before we're no longer the ones calling the shots? Think about what goes into every launch. Engineers calculate orbital mechanics. They balance fuel loads, model thermal cycles, check propellant behavior and microgravity, analyze structural limits under liftoff, and factor in engine chill times, weather patterns, and communication blackouts. It's a mountain of variables stacked on top of each other. And here's the brutal part. Humans juggling this many constraints will miss something, such as a fuel margin inconsistency, a timeline conflict, or a thermal load spike nobody saw coming. When that happens, the error ripples through the entire plan. Launches get delayed, missions get scrapped, and money burns. The current system works, but it's slow and fragile, which doesn't really scale. It delays SpaceX's dream of sending fleets to Mars. You can't micromanage a fleet the way we plan missions today. The old way hits a wall the moment you try to go bigger. Engineers are brilliant, but they're also human. They get tired or overlook things, and they can't test millions of scenarios in a single night. But AI can. That's why SpaceX is about to let AI take the wheel. And when it does, mission planning won't just get faster. It'll become something humans couldn't do alone. But to understand how deep this goes, you need to see what happens when the AI starts making decisions mid-flight. Once Starship leaves the pad, every second is previously analyzed and planned. But the moment something goes off script, the clock starts ticking against you, and it can happen anytime. Because Starship isn't a simple rocket, its ascent has dozens of decision points. The landing sequence has almost zero room for hesitation. On a Mars mission, one delayed burn cascades into everything. Thermal load shift, battery drain accelerates, communication windows close, or solar exposure changes. Right now, when something unexpected happens, mission control scrambles. They recalculate and send updates, hoping the fix works inside constraints they didn't have time to fully rethink. So the problem is speed. Earth to Mars has a 20-minute communication delay. That means for 20 minutes, Starship is on its own. If a maneuver finishes early, the ship just waits. If an engine overperforms, it sticks to the old plan. If tank pressure drops, human engineers on Earth won't know for another 20 minutes. And by then, the situation could be critical. Traditional mission planning assumes everything goes according to schedule. But space doesn't care about your schedule. It will quickly throw curveballs, and amidst that chaos, waiting for humans to respond from a different planet is simply a recipe for disaster. That's where onboard AI changes everything. Starship could carry a planner that updates the mission in real time. If tank pressure shifts, engine overperforms, solar array needs repositioning, AI would take care of everything instantly and automatically. Instead of waiting for Earth, the ship handles the first wave of decisions itself, at least. It keeps the mission inside the safe zone until ground teams catch up and review. This isn't sci-fi. NASA's Perseverance rover already does this. It plans its own daily activities based on what it sees on Mars. SpaceX would just scale that intelligence up for a ship carrying cargo or crew. But these real-time decisions are only half the revolution. The other half is what happens when you stop flying one ship, start flying 10. While sending a single Starship itself to Mars is hard, a fleet of Starships is impossible unless they can think for themselves. Just think about it. 100 Starships are heading to Mars at the same time, where each one needs power during high-demand phases. Each one needs communication windows that don't overlap and trajectory adjustments to avoid collisions. Even better, each one of them has the ability to monitor fuel, thermal cycles, crew activity, and payload conditioning every second. If Mission Control tries to manage all of that from Earth, they'll drown in data. You'd need hundreds of people watching telemetry screens around the clock, plus a constant uplink command for every minor adjustment, and you still wouldn't catch everything. Because the delays alone would cripple coordination, and by the time Earth realizes two ships are on a collision course, it might be too late to stop it. You can't run an interplanetary transportation network like that. So it definitely doesn't work when you're trying to build a Mars base where ships, rovers, habitats, and fuel production systems all need to share resources. In simple terms, the math isn't mathing very well. But if each starship runs multi-agent AI planning, the fleet coordinates itself. They negotiate power usage, share telemetry, plan on communication windows so signals don't interfere, and adjust formation trajectories to reduce collision risk. The AI doesn't just think from one ship's perspective, it evaluates the entire network. So each ship becomes a node in a system that organizes itself. For example, NASA is already testing this concept with the Cadre mission, multiple rovers working together on the Moon. SpaceX would also apply the same logic across interplanetary distances. The ships wouldn't need Earth to babysit every decision, and that frees up Mission Control to focus on strategy instead of micromanagement. But coordination is just the surface layer. The real transformation happens when AI starts controlling how the ships actually fly. Right now, Starship lands the same way every time. But what if it could learn the perfect landing just by practicing 1,000,000 times in simulation? Starship's landing burn is one of the most complex maneuvers in spaceflight. It has to flip, relight engines, fight wind shear, adjust for atmospheric density, and compensate for thrust variations, all while falling toward the ground at hundreds of meters per second. Current approach uses a rigid timeline. The ship follows the script no matter what. If wind conditions change mid-descent, it compensates within narrow limits. But it doesn't rethink the sequence, because it can't, as the sequence is locked in before launch. The problem is that rigid timelines are brittle. They work when conditions match predictions, but when conditions don't match, you're flying with one hand tied behind your back. And here's the thing, SpaceX already runs massive simulation clusters for Raptor engine development. They test millions of scenarios to find optimal performance. They could do the same thing for flight dynamics, train an AI planner through reinforcement learning, and let it practice millions of simulated landings. Let it discover trajectories humans would never think to try, or trajectories that reduce peak loads. If this finally happens, it would cut fuel burns and shorten the time to orbit, but only if they trust the AI to actually fly the ship. Once that trust is earned, Starship stops being a vehicle that follows orders. It becomes a vehicle that adapts. If it senses a more efficient landing trajectory, it tweaks the burn sequence on the fly. Simply put, humans will definitely set the safety boundaries. The AI will optimize within them. This isn't replacing pilots, it's giving the ship reflexes faster than any human could match. And once that capability is proven, SpaceX could attempt maneuvers too risky for rigid scripting, novel ascent profiles, aggressive aero-braking passes, and coordinated multi-ship landings at a Mars base, all designed by AI. All were tested in simulations millions of times before touching the real atmosphere. That's when Starship stops being a rocket and starts being something closer to an autonomous transportation system, one that understands its own limits, one that negotiates with other ships, one that adapts to whatever space throws at it. Complex missions need a system that never tires or loses track. It's never about AI replacing humans. It just handles the countless details we can't. Once that becomes standard, deep space stops feeling fragile and starts looking scalable. And the future SpaceX becomes not just possible, but inevitable. So if a machine can already redesign a rover's day on Mars, dodge thermal risks, balance fuel, and still squeeze in extra science, what happens when it starts planning entire missions without waiting for us at all? And when that day comes, will we still be leading the exploration of space or just watching the future unfold from the sidelines? Thanks for watching. Please subscribe for more videos like this. Hit the like button if you find the video interesting, and kindly provide your valuable feedback in the comment section. This will help us to improve.